a number of bowel accidents are happening in India. This has become one of the biggest problems faced by society. There are many conventional methods used to rescue the child that has fallen into the abandoned borewell. One of the methods is digging hole parallel to the borewell, but this method is time consuming and costly. One more technique that is used to rescue the child is usage of robotic arms to lift the child. This technique poses a high level of risk since there is no support for the child from the bottom. So the risk of child slipping further down is high. So we have come up with a more effective and efficient solution.
For the implementation, we have mainly used 4 DC motors and 2 servo motors. One DC motor for the pulley system, one for the rotation of the disc having a camera attached, one for the rotation of the robotic arms and another for the opening and closing of the robotic arms. All the DC motors have 3 kg torque and the operating voltage is 12 volts. For the operation of DC motors, we have used 2 motor drivers. We have used 2 continuous servo motors with 360-degree rotation for the horizontal and vertical movement of the stick. This stick has a balloon attached to its end and the myRIO interfaces the hardware with the PC.
This is the front panel of the BI that we are using. This window displays the image acquired from the camera, and here Boolean buttons are provided for the operation of the motors. Coming to the block diagram, 3 while loops are used, one for the DC motor control and one for the servo motor and another for the image acquisition from the camera. In the DC motor while loop, enum is used for selecting the motors. The output of the enum is passed to the case statement and 2 buttons are provided for the clockwise and anti-clockwise rotation of the motors, and digital output palette is used for driving the motors. In the servo motor while loop, 2 buttons are provided for each of the motors for the clockwise and anti-clockwise rotation, and based on the buttons pressed, duty cycle values are passed to the channels to which the servo motors are connected. The pulley system descends the robot inside the board. Once the child is found, the pulley motor is stopped, and now, using the rotation of the base disc having the camera, a gap between the child and the wall of the borewell is traced. Once the gap is traced, the stick having the balloon at the end is inserted below the child. The balloon covers entire surface below the child and provides support to the child from the bottom. Now, the robotic arms are operated to hold the child. Now, the entire system is slowly pulled up using the pulley.
By using this technique for the rescue operation, we can avoid the chances of child slipping further down, as the child has support both from the bottom and the top. Since the idea is to provide bottom support, tracing the gap between the child and the wall of the bowel was the biggest challenge. So, we used a camera with a light source, attached it to the disc and provided rotation for the disc. Now, by rotating the base disc, the gap can be easily traced. As a future expansion, metallic plates can be used below the safety airbag to provide extra support to the child. Thank you.